Okay, so this is a problem. Newly common. Cool. So we have a similar problem. So we have the word this is a graph. So rows and no rows is okay. So we have given the graph. The graph is given. Uh, we have undetected edges initially, undetected edge between the nodes, and it is make sure that a road cannot connect the city itself, and also between two cities there is only a single road. Right? Okay, so in order not to cause great resentment among residents, the reform needs to be conducted so that the as being citizens and order not to cause great resentment among residents. We have to reform, yes, to conduct it so that there can be as separate city as possible. The city is considered separated. No road leads to it while it is allowed to have roads leading around the city. Okay, so we need to make the roads in the directional format from the non-directional one in order not to cause great resentment among residents. The reform needs to be conducted so that there can be as few separate cities as possible. Okay, so we need to minimize the separate cities. Now, what city is considered separate? The city is considered separate if no roads leads into it, while it is allowed to have roads leading from this city. Okay, so separate city means that it should not have any in degree, but it can have out degree only. So it's kind of like a hot spot, right? Basically, those it's kind of a hot spot which is having no in degree, but can only have the out degree. So no in degree, only out degree is allowed. Cool, cool. Uh, and we need to minimize such number of cities using the transformation. The transformation is that we can make the undirectional nature to directional nature. Okay, so we need to just see what N and M are 10 power 5. So yeah, that's the input. So basically next and line contain the description of rows. So these are basically the edges which we have there. So these are the edges which we have. It's guaranteed that no more than one road between each pair of cities. It's guaranteed that there is no more than one road between each pair of cities. Cool. So let's take example of this particular code. So 2, 1, 1, 0, 4, 3. So there is an edge between 4 and 3. There is an edge between 1 and 2. There is an edge between 2 and 5. Okay, so this is kind of the initial configuration. And we need to make the separate city as few as possible, right? So, which uh, the president of the board of the Goland decided to make changes road system into each road. Okay, so we each road should be unidirectional. We need to convert each and every road in this case, not only a few roads, but each and every road. Cool. So, yeah, let's just quickly see that code first. And just go. This case means that between one, two, there is a connection between one and two, there is a connection between four and three, there is a connection. Uh, and let's say the output for it will be one. So if I make connection from two to this and let's say from three to this and let's say from three to this, right? What was the initial condition that in degree should be zero? So this particular two over here have in degree of zero, right? And this three and it is having an out degree, and this three is also having in degree zero, but having the out going like this. So over here, like so now we have formed uh, two separate cities, but we need to optimize this result. So instead of this, we need only one in degree towards a particular city. So let's make it one directional. Let's change the direction is huh? Let's make from this to this, and from this to this. Okay. So over here the degree of three has increased, and over here the degree of four has increased. So only one separate city two is available. So yeah, this is kind of a good problem. Let's not take some for example, it's this one. So basically, there is a connection between two and one. There is a connection between one and three. There's a connection between two and three. There's a connection between two and five. There's a connection between four and three. Cool. So output is zero. इसका मतलब हुआ कि total voltage connection connection to the voltage connection. So you get connection. If I uh, okay, so in the second they are saying that let's direct an edge towards loop from one volt. Let's direct an edge towards one because it's already only have two and one is leading towards the outside. One is going away, so one should at least come over here. Uh, Now three definitely, four is isolated, so it should have the in degree. Cool. Five should have the in degree, and my dear, three should also have the in degree. Cool. So this is also the we get from this. That we also have one another example this particular problem. So answer is like five for this, and if I just from one to there's a connection, from two to three there's a connection, and there's also four, five, six, four to five, uh, four to six, 5%. Okay, so this is kind of a cyclic structure. Okay, so when we have such the kind of system, let's say linear system, right? In this linear system, we are having this particular two is having two connections, and this is having one connection. If we have one connection, then we can only make this like this one, and we can only make this one. But we can see that two have become separate now, and in this we try to make as least separable as possible. Let's connect to four. Now four is already connected. No, there's no need to connect it extrally. Let's connect five. Let's six. So in this, component have 0, in this component we have 1, which is your 2. Okay, so how would how would we do this problem? How would we do this problem? Let's think about it. First line of the person is there's two positive integers and M is big enough, M is big enough. So we have the edges given. We need to direct we need to direct each connection. We need to direct each edge. Like, okay. Uh, so if we have a data, if we have a data connection which is non-cyclic, uh, let me just think for it. If we have a system, let's say a Y-shaped system, I have a Y-shaped system, right? So let me just have a Y-shaped system. 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8. Now, uh, I need to keep the count minimum, right? Keep the count minimum. Cool. So let's say I have just direct this, let's just direct this, let's just direct this. Cool. Uh, let's just direct this, let's just direct this, let's just direct this, let's just direct this. And uh, okay, but if we have completely, let's say, neutral system, we have completely neutral, we have completely neutral. Okay, so then also we have one answer. Uh, okay, so if we have a completely linear system, and we have to make connection, we have to connect each edge, so we can do the connection like basically in this manner, like, right? Let's say we have if we have entire linear basis, we have, let's say, a bit of nodes. Right? Then the answer would be one. But let's just see some other test case, much more branched structure. Right. Let me just draw for some branched structure. Cheaper. Cool. Okay, so when I have the branch like structure, I need to somehow connect. Good. I need to somehow connect. Uh, I need to somehow connect. I need to somehow connect. I need to somehow. Cool. And between this system, I need, let's say, with this, I can have two. Uh, so we have answers like 0, 1, right? Uh, so can we generalize this idea? Can we generalize this idea? Can we generalize this idea? I don't know. We need to think about moves. So what I'm thinking is, let's say we have a system like this, uh, very much branched structure, very much branched structure, and there are, let's say, a lot of node points. There are, let's say, a lot of node points, like these black dots, even right, right, right. Let's say I just direct this. I just direct this. 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 Just directors, just directors, just directors, just directors, just directors. I have this single one at the law. So I can say in a very complex base system, I am only and only having only one node which is separate. It can go up to every node, but there is no node which will come towards it. Cool. So this is the branched structure. This is one idea. This is one idea. Let me just see when what will happen when I have the cycle. When I have a cyclic structure, when I have a cyclic based structure with me, cyclic with nodes everywhere. So if I just try to draw it, if I just try to draw it, if I just people to here also here also we have one. Here also we have a one. But when I have purely cyclic, let me just have purely cyclic. Okay, so cool, cool, uh, cool. Okay. Yeah. So when I have a cycle, simply when I have a cycle, when I have a cycle, let's say it is having different nodes. So when I direct this, when I direct this, when I direct it, when I direct it, when I direct, when I direct it. Okay, so we can see that I can make in degree one for each and every. So answer corresponding to it would be zero. But if this case is understood, let me just erase it. Let me just have an example. Let's say this and just an example is basically let's say this. Right. So what I'm having, uh, there are lots of node line between. Right. This was actually border. Okay. So let's say we are having nodes. Um, we are having nodes, and these are nodes. Let's say I connect this, 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 I connect this. Let's this member, this junction over here is have is having integrity one, is having an integrity one. This cyclic system is having non-separable nodes. But the one which is coming from outside, let's say it have three nodes. This was the third one, the same intersection one. And I have to direct this. No, to direct it. But if I direct in this way, the answer is one. But let's say I am, if I direct in this way, okay, so I think that this structure is very much troubleshooting for right. And let's say I present this question for the election. Okay, so this is basically the cyclic structure which happened, right? These are the edges. These are the nodes, and these are the edges. Okay, so from this intersection, I am making everything directed. I'm making everything directed. I'm making everything directed. It itself will have the integrity one. And from this, I direct this. Let's say there are other nodes also attached. 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 Now these are also can be easily directed out. Let's say uh, this connection is leading to some another. This connection is leading to some another cycle. Okay, so okay, we say it is it is not having any requirement, so we can just start directing. Every section will have the integrity one, and particular this section is already sufficient. Let's say we have some inner nodes over here, so let me just make the integrity one. Let me just make the integrity one. Cool. So I'm saying when I have the cycle. Okay, so yeah, so okay. So what I will make sure that graph will have a bit of different components like what we have in this example. And if this is not having, if this is not having any cycle, it will contribute one. If this is having no cycle, it will contribute one. If but it have, but if it have any cycle, it will contribute a zero. If it have any cycle, it will contribute a zero. Okay. And in an undirected graph, how do we detect cycle? It's easy, I guess. Yeah, so first of all, we need the design set union to get the connected components. Not exactly the design set union will be needed. Do I need a design set union? I don't think I will need a design set union because I can when I will use the for loop, right? When I will use the for loop for every node, for every node. If it is not visited, if it is not visited, then it means that the previous node which I have sent from here have marked some of the edges and an answer have been contributed from their side. But this node is the new one, so it will definitely belong to the new component. So I don't know initially that whether I need a design setting or not, but I think I won't needing it. So yeah, we can have BFS or a BFS. We can have a BFS. We can have a BFS based cyclic detection. And this, okay, so let's take a pause. Okay, so let's let the code and do see what happens in this. I think the idea should go pretty much. Let's see happens. Uh, this is not the case. What? Why it's not open? Sorry. What is happening? I cannot. None of the compile is. Isn't that internet is taking it? Let me just try out some. Oh, I think Just a second. Okay. This is yeah. Cool. Sorry. Let's see those ones. Yeah. Yeah. Just get everything pretty much. The component is okay. So there is some doodle left. Let's give it a one. One. Okay. So I do. What were the encoders? What were the encoders? Yeah. Ask teacher. An empty is have to be limited, and each will have one uh edge between those. Okay, so uh I can create adjacency list on no unadapted adjacency list by directional nature. So I don't know. It's just this is a list. Yeah. The stream all lesson plus that I'm just calling those UNV, but they it doesn't essentially mean that it's a U or it's a V because both are directed. It is bidirectional in nature, so I will just put everything into the you know I'll just put that V into the U adjacency list and adjacency list of V will also contain the U sideway walk. Okay, so we have the graph ready. Now for the component connectors, so we have the resulted. Let's initialize it. Let's initialize it with a minus one. And now for all the nodes, I think the nodes are numbered from one to n more specifically. Yeah. Uh, so and yeah, so they are numbered from n to n. So I have to necessarily create the visit of service and plus one and also let's say plus one multiplication is one and we go all the way down at so if visit minus one let's say count is equal to function which I will create I will just pass the node just pass the visit just pass the recency what else let's say and basically as equals to count let's get as a variable equal just keep it function which I'm doing node visit and also refer on adjacency for we will pass this by reference. And now what we will do, we will just have to simply detect whether a cycle is there or not. Cool. So it will be a return type of a boolean. Uh, and if it's a cycle, okay. So we are at the node, we will visit the node. We have to keep a parent node, right? For this purpose, and we will, sorry, we will just, yeah, we will just mark it as visited. And for auto, ID, license, node. Uh, If uh, basically visit of IT, if the visit of IT is first, uh, cool. So we will call this function with the parent will be updated to node and the child will be to IT. We will have the visit, we will have the answer. Uh, over here, some also some condition will be there. And if it's already a visit and it's not a parent, it's a visit. So I'll say if basically my visit of IT is not equal to -1, it's not visited, and if my uh, IT is not visited and also it's not a parent, yeah, then I have to return a true. Like I hope you are getting the logic right. So it's already visited and only a parent is the one which could be visited earlier. I'm saying that it's visited and it's not the parent as well. So we have to return a true. We have to return a true. Okay, and if it's not visited, I will call, let's say, if my this result is uh, naturally, it would be a false statement at the very end. But if that's a true in the VFS, we have to return a true. Cool. Okay, so if this is the condition, I have to return a true, and I will just at the end I will naturally return a false. That yeah, none of this component don't have a cycle, right? Cool. So it would be Boolean. Let Boolean C, which will correspond to cycle. Boolean cycle. Is there a cycle? If yeah, we have a cycle. Then answer was equals to what? Only if a cycle is cool. I hope this logic would work. Let's see if the sample test cases are running or not. Just okay, use some error are there. What's the error? Okay. Visit was not declared. Answer was not declared. I take a note. Consistency. Yes. Okay. And what's so okay, we have some more errors. Boolean node parent. Okay, so we have a Boolean and a parent. Okay, so over here we have to pass the current as a -1. I think it's running and it's printing a 0. What it should be a 1. What was this test case if you remember? What was this test case? What was this test case? Basically, 2 is connected to 1, 1 is connected to 3, this connected to 4, and it's now this should be 1. I don't have any cycle, and my code is 0. I don't know what's happening. Uh, I don't see Boolean shape. Is a cycle is there or not? In this visitor system, is there a cycle? I'm saying it's a cycle. Sorry. If it's a cycle, if it's not a cycle, then clearly, right? If it's not a cycle, then only depend on one. My bad. Let's just see the process. If the game gave in the format of test cases, much easier. I don't have to copy paste each time. So zero and distance zero one. Some ones are running. Let me just quickly try to submit that. Just a second. So I can now answer quickly see it. Yes. Yeah. So, okay. So now it's accepted. Cool. I hope you understand the solution. Let's see another problem. It was a graph problem. It's pretty easy one, I would say. It's 600 rated on code forces. I hope you are doing well. Let's keep watching.